Hello, dear friends. You're welcome to this discussion where we are looking at calculations that involve rates of reaction in chemical kinetics. So the guiding question says the following results were obtained for a reaction between P and Q and can be used to determine the order of reaction with respect to P and with respect to Q and the rate constant. So we are provided with the run, okay? So we did the experiment with the concentration of P being 0.5 and up to E, which is 2.0, for Q 1.0 up to E, which is 3.0. The initial rate, that is the rate of the reaction, was 2.0, and through up to E, where we had 72.0 moles per decimeter cubed. So we are required to determine the order of reaction with respect to P and with respect to Q, and then later on we use our equation or the rate equation to determine the rate constant. So since we are talking about the two reactants, I can say P plus Q reacted to give products. So if they gave products, now that means our rate equation is going to be K times P power X, then Q power Y. So the order of reaction with respect to P is X, the order of reaction with respect to Q is Y. And how do we deal with such a scenario? So we are going to be looking at the results of the experiment, and we look at where P was a constant while Q was varying. That is going to help us to determine Y. Then later we look at Q held constant where Q remained constant and P was varying. That would give us X. So when I look at, for example, 3, let me say 3, at D and E, for D and E, so for D and E, we see that Q was a constant while P was varying. So what are we going to do? So for those experiments, we shall see what is the rate. If we use the rate here, as we can say for E, we can say rate E divided by rate D. This is going to be concentration K. Of course, we are going to put K times the concentration of P. Okay, P here is going to be 2.0 power X times Q, which is 3.0 power Y, divided by K times P, okay, the concentration of P. So this is going to be 1, okay, power X. Actually, let us use now the real brackets. Then here we have 3.0 power Y. So what do you see here? This is a constant, this is a constant, or the same. Obviously, this rate E out of rate D is equal to 72 divided by 36. So what is going to happen is that you are going to have 2 power X, because that's what you have here. This is going to be 72 divided by 36, you get 2 power 1. So here, obviously, X is equal to 1. So how do we determine? To determine Y, we are going to see for those experiments where P was a constant. So we look at P, concentration being constant, while Q concentration is varying. So those experiments where Q is varying and P is a constant, we can take, for example, this A and B. So if we take A and B, so we look at experiments A and B. So we'll find that the rate of B divided by rate of A will equal to K times the concentration of Px divided by concentration of Px times the concentration of Y divided by the concentration of Q. Maybe I call this Q at B, P at B, this at B, this at A, and this at A. So what is that going to be? Obviously, this is going to be 2 out of 1. So that is going to be what? That is going to be okay. So the rate here is 8 divided by 8. It is going to be 8 divided by 2. It's going to be K times, here we have constant at 0.5. So you'll have a K 0.5 out of 0.5 power X, then plus, okay, times what? We have the concentration being 2, okay, 2 out of 1 power Y. So this one is already 1 out of K, so these ones are going, and so what is going to happen? So this is going to be 4, which will equal to 2 power Y. But we know 4 can be expressed in terms of 2 squared. This is going to be this is going to be 2 to power X, and X is, I mean Y. This is Y. So this is Y. And Y is equal to 2. So the equation for the rate of reaction will be rate is equal to K times, this is P. Remember, P was raised to X, so this was 1, and Q was raised to Y, which is equal to 2. So that would give you the rate. So how do we determine K? So to determine K, determine the rate constant K, consider results for experiment A. So results for experiment A are saying you have the rate as 2, then P is 0.5, and Q is equal to 1. So this is going to give us K, which is going to be 2 divided by 0.5 times 1 squared. And this is going to give us, remember the rate is 2 in moles per decimeter cubed per second divided by 0.5 times 1 into mole cubed decimeter to power 9, and yeah, so that is how it is going to be. So this and that will have one going, then for this you'll have also one going, and you'd have a decimeter cubed above. So K will therefore equal to 4 times, okay, per mole squared, okay, then decimeter to power 6, obviously, because this would be 9 plus 3, so which 9 minus 3, which would give you 6, and then per second. So that is it.